two projects. In this video, we are going to explain about the project, which is Dynamic AES Encryption and Blockchain Key Management, a novel solution for cloud data security. So before getting into the execution, first, let's understand what is the project about. So let's say you're using a cloud storage. Let's say you're using a cloud storage to keep important files like personal documents or photos. Typically, in traditional cloud systems, these files they are encrypted using unique keys, and all the keys they are stored in a single centralized server. And now the problem with the setup is that if a hacker manages to break into that centralized server, they can access all the encryption keys and they can decrypt everyone's files. If someone gets hold of those keys, they have access to everything. So it is very important to securely store all the documents or all the files in the cloud. Additionally, insiders of the cloud company, I mean, it may be employees or anybody who are in that cloud company, they can potentially alter or misuse these keys without getting caught, which adds another layer of risk. So, to overcome all these vulnerabilities, in this project, we are proposing a technology called blockchain technology. So instead of relying on a centralized server, this blockchain it allows encryption keys to be stored across many different nodes. I mean many different computers. So this decentralization ensures that even if one node is compromised, I mean if one node is altered, the other nodes will still have the original unaltered version of the keys, making it nearly impossible or hackers to tamper with or steal the keys without being noticed. So this method significantly reduces the chances of a complete security breach. And moreover, in the blockchain, all the data is stored in different blocks. And each block is linked to the previous block in a chronological order, and every block is secured by a hashing mechanism. Hashing is nothing but a digital fingerprint. Rather than blockchain technology, in this project, we are also using AES encryption technique for encrypting the data, which provides a comprehensive approach that makes cloud storage far more secure than traditional systems. Moving on to the type of blockchain used in this project, we have different types of blockchains, for example, Ethereum, Bitcoin, Stellar, Ripple, etc. In this project, we are using Ethereum because it supports smart contracts. And we also have used Ganache and MetaMask. Ganache, it is a user-friendly interface. I mean, it is application where we can monitor all the Ethereum activities. And MetaMask is used to check the ETH price that will be deducted after each transaction. And coming to this encryption part, this project uses dynamic AES encryption technique, which I have mentioned already for cloud data encryption. So these keys, they are generated using XORed. It's a file hash with the blocks hash, ensuring that each key is unique and dynamic. After encryption, the data is further secured using ECC, which is nothing but elliptic curve cryptography algorithm. Instead of centralized key storage, the keys are stored across multiple blockchain nodes, making it difficult for hackers or insters to tamper with or steal the keys. This decentralized and layered approach significantly improves cloud data security. As an extension, to make this project more versatile, two extensions are introduced. First, the algorithm can be modified to work with all types of files, not just images. And we also have used Chacha 20 algorithm, which is incorporated to enhance the performance and also the security. So this Chacha 20 is more efficient and it requires less computational power compared to AES and ECC, which enables faster encryption and also the decryption without compromising the security. So these changes aim to reduce the computational cost while maintaining the strong protection for the data. So this is all about the theoretical part of the project. So coming to the requirements which are needed for this project, we need hardware requirements, which is processor of i5 and above, RAM of 8 GB and above, ROM of 25 GB and above. And coming to the software requirements, we need Python ideally of 3.7.0 version, Node.js, Visual Studio Community version, Ganache, and MetaMask, which is the Chrome extension. And coming to the backend languages are Python is used, JavaScript, and Solidity. Framework uses Django, and front-end languages are HTML, CSS, JavaScript, and Bootstrap 4. Now let's execute the project. To execute, we need to open the code folder which contains source code files. So let's open the code folder. So these are the source code files in the code folder of the project. Now let's understand each of them. How will they be used in the project? So this is the cloud folder. Inside this folder, there are Python code files that are intended to be dynamically loaded into the project code during runtime. And this is the cloud app folder. Inside this folder, we have two subfolders. One is static folder and the templates folder, and we have some Python code files. So coming to static folder, it contains files related to CSS, JavaScript, and Bootstrap files. So these files they contribute to the visual and interactive aspects of the application. And coming to the templates folder, within this folder we will find all the HTML pages used throughout the project. It includes pages like index.html, home.html, and more, representing various sections of the website. And in this contracts folder, we have a SOL file, which is a Solidity code. It handles data structures, functions, and events with modifiers for validation. And this is the manage.py file. It is a command line utility that comes with the Django. And it provides various commands for managing Django projects, including tasks like running the development server, creating database tables, and applying migrations and more. And this is run.bat file. Instead of executing the project through command line interface, we have created Windows bat file to execute the project. So now let's execute it. To execute, we need to host the blockchain server. For that, we have to open the Ganache. So here, if we observe, blockchain is hosted. I mean, blockchain server is hosted. Now get back to the code folder. Double click on this run.bat file. Here, manage.py file is compiled. Now Django framework will host the application locally at the local host and the port. So this is the local host and this is the port. Now copy this local link provided by the Django framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here and at the end type index.html and click on enter. So this is the web page of the project, which is developed using Django framework. So before entering the details, let's open the Ganache and see how many blocks we have in the blockchain. So initially we have four blocks. Now let's enter the details in the blockchain, I mean in the application. Then we will see how many blocks we have in the Ganache. Okay. So here we need to sign up as a user first. So we will sign up as the three different users. So first let's sign up as a user Kumar, give his password, give his contact number, select the gender, give the mail ID, and give his address. Click on submit. So here if you observe, all the details of the Kumar are added to the blockchain. And here if we observe in the Ganesh, we have a new block number 5 created. So this is the block number 5 in which Kumar's details are stored. Kumar's sign up details are stored. So this is the block hash and this is the transaction hash. If we click on this transaction hash, here we have sender address, to contract address, gas used, gas price, gas limit, and transaction data. Let's get back to the application. Now let's sign up as the user Kiran, give his password, give his contact number, select the gender, and give the mail ID. So mail ID would be kiran@gmail.com and give their address. And now click on submit. So Kiran's details are also successfully added to the blockchain. And now if you open the Ganache, click on blocks. Here we have block number 6 created newly in which Kiran's details are stored. And for every block, we will have time and date at when that particular block is created. Now get back to the application. Now let us create one more user. So the other user would be Ramesh. Give his password, give the contact number, give the mail ID, give the address, and click on submit. So Ramesh details are also successfully added to the blockchain. and they will be stored in the block number 7. All the details of the Ramesh will be stored in the block number 7, and this is the block hash. Now let's sign up as the user Kumar. So click on user login link here, and here give the username. Give the username as Kumar and give his password. Now click on login. So user Kumar has logged in successfully, and this is Kumar's dashboard. And here we have three different links. One is upload file to cloud, access file from cloud, and comparison graph. So first, Kumar will be uploading the file. For that, click on upload file to cloud link. So before sharing the file, before uploading the file, let's see how much ETH we have in the MetaMask, because we have made three transactions. We have entered three records. So let's open MetaMask. Initially, we had 100 ETH, but now we have 99.9894 ETH in my MetaMask wallet, as we have made three transactions. Now let us make some more transactions and then get back to the MetaMask and check how much of ETH we have in the MetaMask wallet. So minimize it. Now let's share the data. So here we need to select the users. If we want to share the file for Kiran, we need to select Kiran. If we want to share file for both the users, we can select both the users. So now let us just share for the user Kiran and click on choose file. So let us share this image. Click on open, and here the image is loaded. Now click on submit. So the file is successfully uploaded and it is encrypted using AES, ECC, and also Chacha20. And it is stored in the block number 8. Now, if you click on access file from cloud, user Kumar, he will be able to access his file which he has uploaded. So click on that. So here we have the data owner name, and here we have the file name. He has shared to user Kiran, and this is the AES encrypted key, and this is the uploaded date. And if we click on this download file link, user Kumar will be able to download the file. Now log out and log in as Kiran, because he has given access to only Kiran so that he can download the file. So click on user login here link, give the username and the password. So Kiran has logged in successfully. User Kiran, he can also upload the files. So now let's just access the file, because Kumar has uploaded the file to Kiran. So click on access file from cloud. So here he will be able to see all the details of the file uploaded. And if you click on this download file link, he will be able to download the file. So click on download file. And here the file which he has uploaded is downloaded. Now let's log out and log in as Ramesh and see whether he has given access or not. So click on user login here link, give his username. So click on access file from cloud. So as Kumar, he gave only access to Kiran. Kiran was able to view the file in his dashboard. As Ramesh is not given, he cannot see any file. And even Ramesh, Kiran, all the users who will be signed up to this application will be able to upload the files. And only for those accesses given, they will be able to view the files. And now let's see the comparison graphs of the encryption techniques used. So here in this graph page, we have sensitivity for the existing encryption technique, and this is the sensitivity for the proposed encryption technique. And here if we compare, this is the AES encryption time, which took 4.4126 seconds, and this is the Chacha encryption time. Chacha encryption techniques time, which is 0.045. If we observe, Chacha encryption time is less than the AES encryption time. So by this we can judge that Chacha will take less time to encrypt the file. And here, this is the original image, and this is a histogram of this particular image. And here, if we observe this histogram, the data is not uniform. And if we encrypt this original image, so this is the encrypted image, and this is the histogram of this encrypted image. So this histogram is uniform. So this is about the graph. Now let's upload the file. User Ramesh will be uploading the file. So click on upload file. Because initially we have uploaded image, which was proposed. As the extension, we will be able to upload any file, not only image file. So now let's give access to both the users. Now click on choose file. So let's upload this image, this file. Click on open. File is loaded. Now click on submit. So file is successfully uploaded. And now let's log out and check with the other users whether access is given properly or not. So click on user login here link. Let's log in as Kumar. So Kumar has logged in. Click on access file from cloud. So here if we observe, Ramesh has given access to user Kumar and this is the file details. So if we click on download file link, he will be able to download the file which is uploaded by the user Ramesh. Let's log out and log in as Kiran and see whether he's been given access or not. Click on access from cloud. Here if we observe, Kiran is given with the two file access. With one data owner Kumar who has given one file and the other data owner who is Ramesh who has given one more file access. So if we click on download file, he will be able to download the file which is uploaded by the Ramesh. Now let's log out. Open the MetaMask because we have made so many transactions. Let's see how much ETH we have. So here we have very minute deduction. So which is 99.9892 ETH in my MetaMask wallet. Now let's open Ganache. So here total I have 9 blocks created in my blockchain in which data is stored. So in this way, by using blockchain technology, users they will be able to securely store the data, and by using this AES encryption technique, Charger 20 and ECC, users they will be able to securely store the data in the blockchain. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.